Sorry, I went on mute. So, welcome to this problem solving session on machine learning. Today, we'll be solving questions on the topic um, linear regression and bias variance trade-off. Okay, some issue with the slide, so pardon me for that. As always, my name is Aditya Agrawal, and I hold an MS in computer science from IIT Madras. I'm ex-data scientist from the Higher Ed Technologies, Hyderabad, and I hold a BTech in computer science from the Kalinga Institute of Industrial Technology. So let's dive in and look at the first question. Which of the following is not true about residuals? Higher the better, is lower the better, A or B depends on the situation, or none of these. So over here in this question, the thing to know here is what is the meaning of a residual, right? So now we are talking about linear regression. Let's take some sample data points. Okay, let's take this point, take this point, this point, this point, and this point, or maybe this point. Okay, maybe your linear regression fits a line like this. Okay, let's say this is your line that the linear regression algorithm finds. If you look at this point, right? So this point over here is some x true, and over here is some y true. But if you look carefully, my model will predict that this is nothing but some yp, right? So this part, right, the difference between yp and y true is my residual, is the part that is left, residue, right? Whenever you are trying to fit a line to some set of data points, the amount, maybe amount is not the right word, maybe the difference between what it was versus what did your model predict, that difference squared is called a residual. Now, why is it squared, right? If you've seen my lectures, I had discussed about it, but just to recap for people who have not seen it. So I could also take a, absolute value as well, right? But why I don't do that? So see, again, I have a choice to do that as well. Focus on this point that I'm circling here on the top right. Okay, so if I extend the axis further, then this point corresponds to y true prime. Let's say I call it y true prime, and this corresponding x is x true prime. Now my linear regression algorithm will predict this point as y p prime, and this difference forms my residual, right? If I don't take the square, let's say I take it this way. If I say this value is, let's say I assume it's -5, and this value is, let's say, +5, okay? Or maybe the other way around, because I'm doing yp minus yt, this is 5, and this is -5, okay? So if I try to find the total error, then 5 minus 5 will give me 0, and I can claim that my model has 0 error, okay, which is wrong because you're trying to cancel out the positives and the negatives. So that is why what you do is either you take the absolute value, which is you just omit the sign, or what you can do is you can take the square, right? That way you will be missing out on you will be not having that problem of a negatives. Okay. So if you understood this, now if I ask you a very basic question, right? Residual is nothing but the difference between what it should have been versus what your model predicts. Okay, the y true and the y pred. Do you want that to be small or do you want that to be big? And you might think that it's pretty simple to answer this, right? It's pretty simple to answer this question. it is actually it's always better to have a lower residual, right? Lower the better. The more lower you have, the better is your line, right? So that is why option B will be the right answer. Okay, fine. Moving on. Which statement is true about outliers in linear regression? A linear regression model is not sensitive to outliers. Linear regression model is sensitive to outliers. You cannot say or none of these. So let's take another very basic example of a two-dimensional coordinate system with these set of points. You might find the best line something like this. Okay, again, this is just a guess. You can get some other lines as well. This is my best guess of the line that your linear regression model might predict. Now, let's say there is a point far off, okay, which has a value like this. Okay. Now, you might see the relation that for this point, the x1 here, let's say this is x1, this is x2, this is x3, this is x4, right? Correspondingly, they have their y1, they have their y2, they have their y3, and they have their y4, right? And let's say this point here x5 has its corresponding y5. Okay. Okay. Now, if you see this thing, x5, y5 is very off, right? It doesn't depict the correct relation to the data. But what happens here is, when you're trying to fit the linear regression model, maybe this you are extending this line further, right? And your model will predict some value for this, which is something huge, right? And the residual y5 minus y5 dash, let's say dash denotes the prediction, will be huge. And if you square it again, then it will be more huge. And the one of the reasons why people do squaring is if they want to penalize such huge errors, because as you know, square is an exponential function, right? So 2 square, 3 square, if you go to 100 square, it grows exponentially. If you have seen the graph of x square, y equal to x square, it is something like this, right? So to penalize the higher residuals, you will try to use the squared. But here it's an outlier. So because of this point, you might try to shift your line to something like this. Okay. Maybe I'll use a different color for it to understand. Maybe your model will use something like this. Okay. In that way, this residual and all the other residual will become minimal, right? So just because of the presence of a outlier, this is called an outlier because a data point that is very off from the true relationship of the data. Just because of the presence of this outlier, you will face an issue. And that is why linear regression model is very, very sensitive to outliers. Now, I've never taught you this, but there's another thing here. How would you detect an outlier? How would you say there's an outlier? So for people who are interested, again, this is not in your syllabus, but just for interest, try to look at something called box plots. Box plots are a good tool to detect outliers. Okay, and then you can do outlier treatment. There's something called interquartile range. You can consider all the points that fall in that range. You can consider removing the outliers if you have a huge set of data points. If you remove, let's say, 100 of them are outliers, then you can just remove them. There won't be much of a difference in your model accuracy. Maybe it will become better, but only do it when your model is sensitive to outliers. Okay, so linear regression is actually very sensitive to outliers. Again, I'm not telling you here that if you don't take the square, if you take the absolute value as well, it may still blow up. Okay, it may not blow up in the same intensity as the one if you square it, but it will still blow up. Okay, so this is what it is. So main thing is to know the concept behind it. Just knowing the answer won't help you in the exam. Okay, fine. They in the exam they might give you a sample data set where you can see a particular outlier, and then they will ask, should you remove this point such that your model accuracy will become better. So in other words, they are trying to ask you, is the model sensitive to outliers? Okay, fine. So the next question here is, if we increase the value of k in a KNN, the model will dash the bias and dash the variance. Okay, so I have already taught you a lot about KNN, right? So take 1 minute, think about it, okay, and let me know what you think about this answer. Okay, so you may pause the video as well to know it, right? So actually what happens is, if you increase the value of k, then your bias increases while your variance decreases. So for any machine learning model, if you analyze the error, then there are three principal components. One is the noise in the data set. So noise, you can't do anything as per the model. One is the bias and one is the variance. Variance would mean once you have built the model, then if you look at some random data set, how will your predictions vary? Okay, so if you have a higher value of k, then you are looking at more number of values to find the correct prediction for a particular data point. So if you have some data point that is not present in your original data set, since you are looking at a lot number of values of k, then your model actually generalizes better, in the sense the variance is very reduced. Okay, variance would mean if you look at an example data point which is not in your data set, how will the predictions vary? Okay, so if you increase the value of k, then your predictions will be more spot on because you are looking at more number of values. It's more like if I ask you, which college do you want to join in GATE? Okay, if you ask 10 people, your prediction will vary a little less compared to if you ask just two people, right? If you just ask two, I might say go to IIT Madras. My friend from ISC Bangalore might say go to ISC Bangalore. If you ask 10 people, then you will have a more better answer to it. Your variance will reduce, right? But here is the thing. So other thing is your bias increases. Okay. So to understand that, understand what happens if the value of k is 1. If the value of k is 1, then you are only looking at one data point. You are only, whatever decision you are taking for this data point, whether it should belong to which class, you are only looking at one data point. In that case, your variance will be huge, right? Because if you see an unknown data point, you're just looking at one nearest data point to it, and then deciding the prediction, and then deciding your answer. Your variance, your model will vary a lot, right? But sorry, your variance will be huge. But if you look at the bias, your bias would mean you are not actually looking at each and every other data point. You are only considering one, right, and taking a decision. That's it. I'm only considering one. Okay, it's more like if you increase the value of k, then you are kind of saying the model that, hey, just one data point is not enough actually to make a prediction. Maybe I need two, maybe I need 10, maybe I need 100, right? So you're increasing your bias, right? You are increasing your bias. Okay, again, I've explained this thing very well in the video. If you don't still understand, please watch my video on KNN. What I'm trying to say is, if you increase your bias, you're taking more number of, you're not looking at the model that much. You are saying that, oh, I don't trust this data point because k is 1. No, because if let's say k is 5, I don't trust only one data point. I need one more data point. Maybe one more data point, one more data point. That way, what you can do is your bias will increase. And if your bias increases, subsequently your variance decreases, right? And that is what is the answer. So if you increase the value of k in KNN, the model will increase the bias and decrease the variance. Okay, fine. Moving on to the next question. Huh. So in a logistic regression, if the predicted logit is 0, what's the transformed probability? So again, you learned logistic regression. Think for a minute, take some seconds, 10 seconds, 20 seconds, and then we will discuss the solution. Okay, sorry guys, I was actually talking on mute all this while. Okay. So in a logistic regression, if the predicted logit is 0, what's the transform probability? So as you all know, the logit, right? So the logit of x is log of x by 1 minus x. And then you have to find the value of x, right? So given this value is actually 0, right? This is 0. Then you can write this as x by 1 minus x is equal to 1, right? And that means x is equal to 1 minus x, and you can find the value of x as 0.5. Okay, so please remember this function. The log it of x is log of x by 1 minus x, right? I may not have taught this. I don't remember if I taught this. Okay, but this is not very important also, but make sure you're just aware of the formula such that if you are given any such questions like this, then you can answer it as well. Okay, fine. Let's go on to the last question for this video. If you are given n independent input variables from x1 till xn and dependent target variable y, a linear regression model is fitted for the best fit line using the least square error on this data. The correlation coefficient of one of its variables, say x1 with y, okay, sorry about that, x1 with y is minus 0.97. Which of the following is true for x1? Is the relation between x1 and y weak? Do you call it strong? Do you call it neutral? Correlation does not imply relationship. So first let's understand the question, okay? Then we will solve it. First, the main thing is to understand the question. You are given n independent input variables from x1 till xn, which means there are n features in your data sets. Okay? And you have a dependent target variable y, and you are trying to fit a linear regression model to find the best fit line possible, and you are using the least square error on this data, finding the residual, and you are minimizing it. The correlation coefficient of one of its variables, let's say x1 with y, is minus 0.97. Which of the following is true for x1? One thing that you need to understand here is what is correlation, right? So I'm not here to teach you statistics. I don't want to take a full lecture on correlation today. But what correlation means is, let's take by a simple example. If you have two variables x and y, let's say I write a very basic data set. Sorry. Let me write it again. Okay. Not good to overwrite, right? So let me write it again. 3, 4, 4, 5, 5, 6, 7, 8, 9, 10. Right? 9, 10. So now you can see very clearly that it is nothing but y equal to x plus 1. Right? You might have heard a background noise. Sorry about that. Okay. So y equal to x plus 1. Right? And if you see, whenever x increases by 1 unit, y also increases by 1 unit. Right? Can you see that? Whenever x increases by 1 unit, y also increases by 1 unit. So these two variables are highly correlated. They are correlated. They are related to each other, right? So this becomes a very important feature. And there is a coefficient called Spearman's coefficient correlation. So the value of the coefficient should be from minus 1 to 1. And if I tell you the correlation coefficient between x and y here is a pakka one, perfect one. More it is towards 1, which means with the increase of one variable, the other increases in the same manner, in the same set of manner. So if it is perfectly like whenever x increases by y, y also increases by 1, that's called a perfect correlation, and that way you can get 1. Now, what is meant by minus 1? So think of another scenario, x and y. Again, I have from 1, 2, 3, 4, 5, 6, 7, 8, 9. And let's say it's something like this. So over here, if you see, y is actually x minus 1, right? Whatever is the value of y, with one increase in the value of y, sorry, x, if one increase in the value of x, y decreases by the same amount. Y also decreases by 1. So here the coefficient of correlation will be minus 1. So with the increase of a variable, if the other variable also increases, it is a positive correlation. With the increase of one variable, if the other variable decreases, then it is called then it is a negative correlation. So in that, the correlation coefficient of one of the variables, let's say x1 with y is minus 0.97. Which of the following is true for x1? What can you say about x1? Okay, if you guys want to think, you can pause the video here, think for some time, and then answer it after you have heard my the concept that I taught you. So here, if you see, with 1 unit of increase in x, right, y decreases, but maybe not in the same manner. Maybe not like -1, maybe like, I don't know, maybe minus 0.97. Okay, it's not a perfect correlation, or maybe there are some points that decrease or absolutely like that. With 1 increase in x, y decreases with 1. Some points do not increase like that. There could be some variation in that space. So that's why it's not a perfect -1, it is minus 0.97. And this also means that the relation between x and y is very, very strong, even though it's negative. So you can, so if you, let's say, have this, right? So I will give you one more tip today. If you have this, if you have any other feature, right, actually you won't need that feature. You can just use this x1 and then calculate this model. This is the function, right? This is the hypothesis of the machine learning model. And then whatever you get data point, you just look at x1 and find the value. This way you are able to do feature selection as well. And feature selection by correlation is one of the very important topics in machine learning, which you don't have in your syllabus. But again, if you know machine learning before, or if you have worked, or if you will work, if you are well interested, then you will definitely find this. You will have to find the correlation between individual features. It could also happen that, let's say, let me give you another small example. Okay, so let's say there is another feature, x2, which is like 2, 4, 9, 16, 25, 36, 49, 64, 81. So if you see, x2 is nothing but x1 square. So with 1 unit of increase in x1, x2 also increases in this, x2 also increases. They are highly correlated, right? You can say that x2 is x1 square. So you're not actually getting any other new info from x2. Whatever is x1 is just a square. x2 is just a square of x1. It's not a whole new feature that can help you to do the predictions. So you can also remove x2 in that case. So feature selection by correlation is a very important feature selection technique that you can use in your machine learning projects as well. So if you have understood that, well, again, let's come back to the question itself. Y being minus 0.97 is also considered a good amount of correlation between the two variables. And that is why, which of the following is true for x1? Relation between x1 and y is very strong. Okay. The only thing confusing might sound is a negative sign. It might be weak. No, minus means it is actually very strong as well. You look at the correlation coefficient. To look at you have to look at the absolute value or the magnitude to actually deduce that whether they are correlated or not. Okay. So again, thank you for joining this lecture. For maybe that clears your concepts a bit more. You get to learn a bit more and know a bit more stuff regarding GATE in particular, and GATE DA and machine learning. Okay. And this is the first time that the GATE DA paper is happening, so no one can predict what questions are there. But these are the best bet of questions that I can think that might be asked in the exam. Okay. So we'll meet in the next lecture. Again, if you like the video, please feel free to ask any questions you have, like, comment, and subscribe. And make sure you visit our website to know more. If you want to enroll in our GATE courses, make sure you visit our website, inquire about them. Number is given here. You can also email us at info@iitiansgateclasses.com. Right. With this, I would like to end this lecture today. Thank you for listening.